Welcome to Duncan Hall, home of Rice University's Computer Science Department. Let's do our first Hello World example of parallel programming. We're going to try the array sum example that we had discussed earlier, and we will use the async and finish notation, which is made available in an API to you. So here we have a sequential version that has conveniently been split up into two parts for computing the sums of the lower half of the array and the upper half. And now our job is to create the parallel version. Now what we've done is, to begin with, we've just copied the sequential version into the parallel version, and if I run this code, we will print out the execution time for the two versions. This of course depends on the machine that you run on. On my laptop, we can see that we are getting times of about 464 milliseconds or 450 milliseconds for the two versions, and that's not a surprise because they're identical right now. Our job is to make the parallel version go faster. So what we're going to do is, well, we need to use parallelism, so we're going to create an async task. So here we have an async. And what we'll do is we'll wrap the computation of the lower half of the array into an async, and let's see if that works and if we can run the program. So what we are doing is we're computing the lower half of the array in parallel in an asynchronous task, and then we can compute the upper half of the array sequentially while the lower half is being computed. Let's run it and see what we get. And wow, we are immediately seeing a difference in time. You can see the sequential version is still taking about 450 milliseconds. This is for adding up 100 million elements of an array and taking their reciprocals before doing the addition. The parallel version is about 215 to 216 seconds, so that's slightly more than 2 times faster. And we are only using 2 tasks, so actually we're doing a little better than what we could expect theoretically, which is great. But there is an issue. If you look at some of the runs, like this one over here, we see that the answers are different. The sequential one has 18.99790, and the parallel one has 18.99723. That's not okay. We want the program to run faster, but we want it to generate the same output as before. Well, if we go back and take a look and see what happened, we forgot to put a finish. So what's happening is there was a data race, a special kind of bug that we learn more about on the variable sum1, which was being computed in parallel by the async and then used later. So to get rid of that data race, we need a finish, and we can do that again using the API with the Lambda interface that's available in Java 8. And let's format it all so it looks prettier. Missing. And let's try and run it. So we're still seeing the faster times. You can see for the last run it was 460 seconds and for the sequential version, and 220 seconds for the parallel version. But in each case, the outputs are identical now, and that's exactly what we wanted. By putting the finish, we fixed the bug, but by using the async, we were able to get our desired parallelism. So there you have it. By the simplest of parallel programming primitives, you can directly see speed up on your own computers, and this will be the starting point for the other concepts you learn in the class and also for your programming assignments.